so this is our Honors Chemistry lesson video for section 9.3. And if you've made it through the chapter 8 videos, I'm sure you're exhausted. So the good news is this one's super easy. Alright, so today we're going to talk about naming compounds that start with nonmetals. So remember, nonmetals are to the right of the stair step on the periodic table. They also include hydrogen, but most of the compounds I give you that start with hydrogen will be acids, and we'll talk about those in section 9.4. So when naming with nonmetals, you name the first element and add "-ide" to the second element. So that's very similar to how we name when it's a metal and a nonmetal. So now it's just two nonmetals. You must also add prefixes to indicate the number of atoms of each element. The only time you do not need a prefix is when the first element only has one atom. So if you've ever heard of things like di and tri and you've been wondering why have we not been using those when we name, it's because you only use them when you name compounds that start with a nonmetal. So these are the prefixes you need to know, 1 through 10. 1 is mono, 2 is di, 3 is tri, 4 is tetra. That one's commonly missed. A lot of people want to say quad. But if you've ever played the game Tetris, it always drops 4 blocks at a time. So that might help you remember tetra. 5 is penta, 6 is hexa, 7 is hepta. I get septa a lot for that, but it's hepta. 8 is octa, 9 is nona. A lot of people want to put nano, but it's nona. And 10 is deca, like a decade. So remember, the only time you don't use a prefix is if the first element only has one atom or no subscript. Okay, so of course we want to call this water, but when we're officially naming it, we know H is hydrogen. Our prefix for 2 is di, so it's dihydrogen. And then O is our second element, so we're going to call it oxide, not oxygen. And then it technically has a subscript of 1, so we're going to call it monoxide because our prefix for 1 is mono. Okay, so water is officially called dihydrogen monoxide. So the second element always needs a prefix. The first element only needs a prefix if you see a subscript. So like on this one, C is carbon, but I'm not going to call it monocarbon. You'll never start a name with mono. Remember, the first element only has a prefix if it has a subscript. And so then oxygen is oxide, and this time there are 2 of them, so I'm going to call it carbon dioxide. And remember, the second one will always have a prefix, so it will use mono sometimes. All right, so our last one is CO. So C is carbon. Remember, the first element does not need the prefix mono. And then O is oxygen, of course, but we're going to call it oxide. And since there's only one O this time, we're going to call it monoxide because our prefix for 1 is mono. So again, you can use the prefix mono for the second element, but just never the first element. And most people, they like this form of naming the most once they learn the prefixes. All right, so maybe pause the video and try these real quick, and I'll assume you've done that, and let's look at them together. So Si is silicon. There's only one of them, so I don't need a prefix. Br is bromine, which we'll call bromide, because of course we need to change anything to ide. And then there's 4 of them, so our prefix for 4 is tetra. So silicon, tetra, bromide. And I know all of these sound really weird in the beginning, but you'll get used to how it sounds. Permanganate probably used to sound weird too until we used that one in our polyatomic ion list. All right, so this one, N is nitrogen. And it does have a subscript of 2, so I do need to put a prefix, so dinitrogen. And then O, of course, is oxide, but it has a subscript of 5, so that would be penta. So pentoxide. So hopefully you're getting these right. So dinitrogen, pentoxide. Then our last one, we have nitrogen. There's only one of them, so I don't need a prefix. And then hydrogen, when it's at the end, is pronounced hydride. Hydride. And since there's 3 hydrogens, it's nitrogen trihydride. Okay, so the important thing is don't forget to put "ide" at the end, and don't forget to use your prefixes when you need them. Remember, you only need a prefix on the first element if it doesn't have a subscript. So now let's look at the opposite way. What if I give you the name and ask you for the formula? So when writing the formula for a compound that starts with a nonmetal, this is the one time you don't need to balance charges. You don't need to because the prefixes tell you how many atoms. You can't balance charges in a molecular compound. They aren't charged at that point. They're sharing electrons through covalent bonding like you just learned in this chapter. So here's some examples. The thing I hate about this, hopefully you can look at it for a second and you know me well enough to know what I hate about this. I hate no. It's not that they gave us the weird British way to spell sulfur. It's that that is a capital L, and we all know the second letter of an element is always lowercase. So, you know, you might think, well, then why did you put that picture up there? I don't know. I probably should take it down. But anyway, I didn't make that picture. I stole it off the internet. All right, so it says write the formula for the following compounds. So we have carbon tetrachloride. So again, I don't need to focus on charges because the prefixes tell me everything I need to know. So it says carbon, so I know that's C. Tetrachloride, chloride is Cl, lowercase l, just saying. And tetra means 4, so it's CCl4. That's all you have to do. Super easy. Sulfur hexafluoride. Well, sulfur is S. It has no prefix, so I can assume there's 1. Fluoride is F, and hexa means 6. And so that's all you have to do. This is why people favor this type of naming system, because you don't have to remember to cross charges. All right, so maybe pause it, try these, and then we'll look at them together. So I'll assume you've done that. So we have diphosphorus, so phosphorus is P, di means 2, trioxide, oxide is O, tri means 3. So hopefully you got that one right. Bromine monoiodide, so bromine is Br. Since it doesn't have a prefix, I can assume there's 1. Iodide is I. Since it has a prefix mono, I know there's also 1, so it's just Bri. So like I said, hopefully you're finding this type of naming for molecular compounds pretty easy. So let's knock out our section assessment. See, I told you this video is much shorter than the chapter 8 ones. So what information do prefixes tell you? Well, they tell you the number of atoms. So if it says diphosphorus, I know there's 2 phosphorus atoms. Whoop, kind of started making a little 8 there. All right, so it says write the name for the following molecules. So we have Ni3. So N is nitrogen, no prefix needed for the first element if it doesn't have a subscript. I is iodide, and 3 is tri. So it's nitrogen triiodide. Next one, we have B, which is boron, no prefix needed, and 3 Cl's. So that would be trichloride. And don't forget to add that I at ending. Our next one, we do need a prefix because see how Cl has a subscript? So 2 Cl's is dichlorine. Now be careful, we're used to changing chlorine to chloride. That happens when it's the second element. Here it's the first element, so it's just dichlorine. And then there's 7 oxygens. Well, oxygen's oxide and 7 is hepta. So it's heptoxide. And you may notice that when I follow with like oxide, I drop the A or things like that on the prefix. If you forget to do that, I'm not going to mark it wrong. But again, if you're not in my class, you might want to check with your teacher. They might be super big on spelling. I will expect you to eventually be able to start doing that thing. All right, so our next one, we have S, which is sulfur, no prefix needed. And we have 3 O's, which would be trioxide. All right, our next one, we do need a prefix on the first one because it does have a subscript, so 2 N's would be dinitrogen. All right, and then remember what I told you about hydrogen. When it's negative, it is called, or sorry, not when it's negative. When it's listed second, it's called hydride. It's also called that when it's negative, but it's not negative in this case. These are molecular compounds. But there are 4 of them, so it's tetrahydride. So dinitrogen, tetrahydride. All right, our next one, we have 2 N's. So again, I'm going to start with dinitrogen. And we have 3 O's. So I'm going to end with trioxide. And so again, notice all those I endings. And then last one, we have C, which is carbon, no prefix needed because it doesn't have a subscript. And then 2 S's would be disulfide. 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 So again, these just take a little bit of practice, and then, like I said, most of the time, naming with an element, when a compound starts with a nonmetal are people's favorites. So let's go in the reverse a little bit. So write the formula for the following compounds. So we have carbon tetrabromide. Well, carbon C, bromide's Br, tetra means 4. And that's it. No crossing charges. Phosphorus pentafluoride. Phosphorus is P, fluoride is Cl, penta means 5. Iodine heptafluoride. Iodine is I, fluoride is F, hepta is 7. Chlorine trifluoride. Chlorine is Cl, fluoride is F, and tri means 3. And then last one is iodine dioxide. Iodine is I, oxide is O, di means 2. So number 4, it says the name a student gives for the molecular compound SiCl4 is monosilicon tetrachloride. Is this correct? Well, hopefully you realize no, it's not correct. Why? Remember, the first element should not have mono. Remember, the first element only has a prefix if it has a subscript. So no, the first element should not start with mono. So remember, the first element only has a prefix if it has a subscript. Alright, so the last thing we have to do is we're going to have to jump a little bit back into chapter 8 real quick, because we are going to do our last question, everyone's favorite, our sample integrative exercise. So it says, elemental sulfur is a yellow solid that consists of S8 molecules. The structure of the S8 molecule is an 8-membered ring, so it's going to be like a stop sign, kind of. Heating elemental sulfur to high temperatures produces gaseous S2 molecules. With respect to electronic structure, which element in the second row of the periodic table is most similar to sulfur? Well, y'all, elements in the same group are similar. So which one in the second row is in the same group as sulfur? It would be oxygen. Okay, and then they would have a similar ending in their electron configuration. So oxygen and sulfur would be most similar because they're in the same group, so they have similar electron configuration ending. Alright, so let's move on. So it says, use the Vesper model to predict the SSS bond angles in S8 and the hybridization at S in S8. So here we go, back to chapter 8. Alright, so first let's draw it. So we have S8, S is in group 16, so it has 6 valence electrons, and there's 8 of them, so we have 48 valence electrons to work with. So it told me it's an 8-membered ring, so I already know how to set it up. So I'm going to do one here. Ooh, okay, 8 members is awkward. Alright, so remember, we added up our valence, I've single bonded everybody, it told me it's a ring, so I put it in a ring form. Now we've got to make everybody stable. So if you look, every S has 2 bonds right now, which is 4 electrons. So I need to add 4 more electrons to each sulfur. Now, for the sake of the fact that you just watched a million hours of the chapter 8 lesson videos, I'm not going to count all those. It's 48 electrons. So this is what we have going on here. Alright, so it says predict the bond angles and the hybridization. Alright, so for our hybridization, we can see the shape is bent, but our electron domain shape is tetrahedral. You can see how you have the 4 locations. So since our electron domain shape is tetrahedral, our hybridization is sp3. Since our shape is bent, remember, it's going to have bond angles approximately 109.5 degrees. Okay, yes, we know those valence electrons take up more room, and they're going to kind of try to squeeze those together, but because this is an awkward ring structure too, that's going to kind of open it up. So for this one, I would just put the approximately 109.5. Alright, so let's move on. I think there's just one more part. This sample integrative exercise wasn't too bad. Alright, so it says using the average bond enthalpies in table 8.4 to estimate the enthalpy change for the reaction just described, is the reaction exothermic or endothermic? All right, so instead of me clicking back, let me just write what the reaction was. So it's S8 yields 4S2. All right, so we know S8 is made of single bonds between S and S. We don't know what S2 is yet, so let's look at what S2 is. So S2, S has 6 valence electrons, but there's 2 of them, which is 12. So I'm going to single bond and make everybody stable. But I have 2, 4, 6, 8, 10, 12, 14 electrons. Remember, I'm only allowed 12, so remember, for every 2 extra, you add 1 extra bond and get rid of 2 of your dots. So now I have 2, 4, 6, 8, 10, 12. So an S2 is an SS double bond. So you got to be careful with that. So what exactly are we doing here? So remember, our delta H is our bonds broken minus bonds formed. So I have 8 SS bonds. So I'm going to take my 8 SS bonds and I'm going to subtract my 4 SS double bonds. All right, remember, bonds broken minus bonds formed. So if you look at your table 8.4, which you have in your packet, your bond enthalpies, for our SS bond, we get a number of 266 kilojoules. And for our SS double bond, we get a number of 418 kilojoules. So once I multiply this number by 8 and this one by 4 and then subtract the 2, I get 456 kilojoules. So see, that wasn't that bad. A little flashback to chapter 8. Alright, so to see the last way of doing naming, make sure you watch the section 9.4 video. And I'll also be making a kind of little review video of 9.1 through 9.3, just so you can kind of get it all right there next to each other.